Ladies and gentlemen, good day to you all. I'm Johnny from SEER, responsible for the AMR product and application. Today, I'm excited to present to you an overview of the common models of autonomous mobile robots, AMRs for short, and their components, as well as detailed introduction to our featured model, the wheeled robot base, and the lifting robot. AMRs come in various models and are widely used across different industrial and scenarios. To meet a variety of application needs, SEER has launched different models as shows in the picture. All these AMR use differential motion models, laser slam navigation, QR code navigation, and their different size and the maximum load capacities can meet various application needs on site. The lifting AMR model slides under the bottom of the rack and lifts it up with a special mechanism. This way, it moves materials around, save on labor costs, and take the stretch off workers. Next, there are two videos show how AMR works on site. The first video shows the transportation of the mobile racks. Okay, the next one is show the interaction between AMR and the elevators. All right, next, we will dig into the details of our featured model, the SEER lifting AMR. Right now, we got the AMR model here, so we can get a clear visual sense of what's inside. The structure of this robot mainly includes the following parts. The first and the most important is the SEER SRC controller. It's responsible for the robot's path planning and motion control, which is the brain of the robot. The second part is the laser scanner. It's the perception components used for navigation and the safety detection, which is the eyes of the robot. The third part is the drive and control unit, including walking drivers, lifting driver, encoders, reducers, motors, and so on, which are the execution units and use the difference in speed between the two walking motors to rotate. The next one is chassis, including suspension and shock absorption, providing a stable foundation for the robot's movement. Besides that, this lifting AMR has a really smart navigation and SRC control system. It can recognize QR code with a camera rack legs with a laser scanner, and do other cool recognition stuff. Plus, it can avoid obstacles with lasers and 3D cameras, and finds a way around them. It's highly versatile and ideal for smart manufacturing. In summary, AMRs are versatile and come in various forms. They are essential for modern automatic factories. The lifting AMR, with its advanced technology and reliable performance, is a powerhouse in the smart manufacturing sense. Next part, we're going to look at the core components selection. First is a very important part is the drivers. When it comes to motors, you've got to pick the right driver for the job. For example, if you've got a DC motor, you will need a driver that keeps the speed steady. But if you are dealing with an AC motor, you will want an AC driver. Plus, you've got to think about things like how much power the motor needs, the voltage, and the current. Make sure the driver can handle what the motor needs to do its things. Here is a moon drivers for lifting control. And this is the Kinco driver, usually for working control. To keep the robot power up and moving with pin-powered accuracy, we usually opt for a direct current servo system to handle the power. This system talks to the controller using the can open protocol. When we are setting this up, we need to look at the details like how much weight the robot will carry, how fast it needs to move, and what task it will be performing. Kinco is a brand that's often used for their reliable and high-quality drivers. They've got a pretty wide range of power options from 100 volts up to 1500 watts, which pretty much covers all the power needs for any kind of lifting mobile robots you might have. When it comes to choosing between incremental and absolute encoders, the incremental encoders are typically equipped with working motors. While motors requiring positioning control can select absolute encoders, such as the rotating motors of steering wheels. This is the safety encoder from SICK for functional safety use. Once select a motor with an absolute encoder, then the driver also needs to be supported. The benefit about the absolute encoders is they can remember where zero is, even if power off. But they do need batteries, which you might need to swap out over 3 to 5 years. On the other hand, the motors and the drivers with incremental encoder usually cost less. So next, we will look at the navigation components. Usually, we recommend the single beam radar for indoor use. First, we strongly recommend is the Pepper-Fox R2000. The scanning angle is 360 degrees, measuring range up to 25 meters. Angular resolution is 0.05 degrees. And we also recommend the scanner from SICK, NanoScan 3 Pro. The scanning angle is 275 degrees, measuring range up to 40 meters. Angular resolution is 0.17 degrees. Besides, we also support the multiple beam radar for outdoor use. like LopeSense Helios series. The field of view in horizontal is 360 degrees. In vertical is about 30 degrees. Measuring range up to 150 meters. Angular resolution is 0.2 degrees. Besides, Sears controller also support the optical reading head. It's for QR code navigation. It's also from the Pepler folks. PGV 100R and F200. The accuracy arrow is plus minus 0.2 millimeters and plus minus 0.1 degrees. This insulation height, which is the distance between scanner and the QR code, is about 100 millimeters plus minus 30 millimeters. The lifting AMR supports navigation scenarios with laser slam, QR code navigation, and a mix of both. When selecting laser and camera equipment, you need to consider the working field of view, lens, and whether it's indoor or outdoor environment. For very open space, like large workshops or warehouse, you should choose navigation lasers with a longer effective scanning range. When navigating with reflectors, to be honest, it's not recommended to use 6 sensors for testing results. In scenario where high positioning accuracy is required, it's suggested to use a combination of laser slam navigation and the QR code navigation. The QR code can be used for secondary fine positioning after reaching the target location. All right, after that, we were looking at the obstacle avoidance components. Sears controller support the single beam LiDARs from 3 sensors. Model is the C214. The scanning angle is 270 degrees, measuring range up to 25 meters. Angular resolution is 0.33 degrees. It also has the pros. It has a large effective sensoring range, high precision, and it can be used as a navigation laser. But the cons can only detect a single plane. That's why Sears controller also support the 3D LiDAR from Livox Mid 360. The FOV in horizontal is 360 degrees. In vertical is from -7 degrees to 52 degrees. The measuring range up to 70 meters. Angular resolution is 0.15 degrees. It also has a pros. It often offers 3D optical detection and high precisions. The cons is the field of view is limited and the cost is a little bit higher. So next, we will look at the energy components as the picture shows. The picture shows the modular battery provided by Sears. The nominal voltage is 51.2 volts. Nominal capacity is 23 amps hours. After 2,000 charge cycles, the battery capacity is still at or above 80%. With plug-and-play tech, you can easily hook up to 5 battery packs side by side. This means you get even more the power and the battery life. And on the left, it's the Sears charge station. There's a SRC 880 controller inside, enable the automatic charging function. It can offer a communication interface and signals for AGV monitoring, like charging, standby, full charge, and error status. and exchange real-time data and work status with the host computer. It's also able to supply voltage and current output from 1 to 60 volts and 10 to 100 amps. Since the SEER controller supports third-party batteries, so for the battery selection, the following parameters need to be considered. First is about the discharge rate. The battery's discharge rate, also known as the C rate, indicates how well the batteries can handle discharge. Based on the robot's power needs, the battery must be able to work steadily and the robot's maximum load. The second is the cycle life. The cycle life of lithium batteries tells you how many charge-discharge cycles the batteries can go through without significant losing capacity. Choosing a battery with a high cycle life can reduce the frequency of replacement and lower long-term costs. Operating temperature range, depending on the robot's works environment, make sure the batteries can operate with a specific temperature range to ensure it maintains maximum performance in both cold or hot condition. And consider design heating or cooling structures accordingly. Next is about the voltage and the capacity. The battery's voltage and capacity determine the power and energy storage it can provide. Ensure these parameters match the robot's energy needs to meet the vehicle's insurance requirements. The last one is about the charging time. Depending on the robot's usage, choosing a battery with appropriate charging time can be very important. A battery that supports faster charging can increase the robot's operating time and efficiency. So, next part, we will talk about the communication equipment. The SRC controller comes with a built-in wireless card, but to adapt to different on-site network environments and ensure the quality of network communication, we usually add extra wireless equipment. In this case, the built-in card on the SRC controller should be disabled. Next is about the HMI unit. The SRC controller supports connection to the wireless HMI device, like touchscreen from KingCode, speakers, light strip, emergency stop, and even Xbox joysticks to control the AMR, and so on. The last part is about the recognition of the carriers. The main load for the limit lifting AMR is the racks, single or multi layers, including some pallets with suitable heights also works. So the lifting AMR usually uses a laser scanner for rack leg sharp, like this. Recognize or add the reflective tapes as add. For the lifting AMR that navigate purely with QR code, they do not have the function to recognize the racks. But for black racks, reflective tapes must be attached to the legs to ensure normal recognition. Okay, the last part, we will look into the vehicle calibration with RobShop Pro. As you may see in the screen, RobShop is the engineering software for commissioning use. First, we can open the RobShop and connect to the mobile robot. And the map control taskbar, you will find the others and find the calibrate robots. You will find very many items need to be calibrated. But due to the priority relationship between calibration items, different calibration items need to be automatically calibrated in order. You can find out the details in the operation manual, of course. Here's a video where show how the calibration works. Because there can be errors during the manufacturing of the vehicle body, sensor installation, or components mounting, calibration is a necessary step before putting mobile robots into use. It involves sending specific motion commands to the robot, collecting sensor data during the process, and then calculating corrections to the parameters of a specific model files to make them more accurate to the real condition. The main objects for calibration include laser, odometers, and the steering wheel angles. After you go through all the calibration steps, RoboShop will pop up a window to show you the result, and you can follow the properties to proceed. In the video, it shows sending commands to move the vehicle to a station to demonstrate precise positioning. Okay, that's all what I share with you guys. And the last part is about the Q&A part. Let's look at what kind of questions in the comments. Okay. If you need have more questions later, so you can leave or either in comments or just leave the message on our website. Our expert will contact you later. Thank you for listening. See you later next time.